And here we are, guys, the final question, so number 9. Now this one in particular was a lot easier than last year's paper for 2017. Okay, this one is actually straightforward because you just require a rectangle and integrate underneath the curve to find the area R. Anyway, let's have a look. Yeah, and oh yeah, a few things I noted. So I call this TP, so I call this one the turning point because this is where it turns. And to find a coordinate of the turning point, remember that this is when the gradient is flat. So that means when you use dy dx, it equals 0, because this means a 0 gradient. Okay, and that's it. Let's have a look. So now this figure here shows a sketch of part of a curve with a given equation. Okay, my tip here right now is to expand the bracket, yeah, to get something like this. And if you're not sure how to expand it properly, you got 7x squared times root x, and root x is the same as x to the power of half. So 7x squared times x to the power of half, you add the power, so you get 2 plus half, which is, and I just wrote it simply as 2.5. Because this is C2 not C1, always write things, especially powers, if they're in decimal, preferably in decimal form, because when you integrate, it's easier to not mess it up. Okay, and differentiate is easier to not mess it up. Now let's keep going. So the curve has a turning point at point A, so that's why I call it TP, and we know that by differentiating to get the coordinates, and then so on. So A, using calculus, find the coordinates of the point A. Now straightforward. In other words, we got the curve here. Here's at this point. Let's dy over dx this equation right here. So when I did that, I got 70x minus 35x to the power 1.5. Quick tip here, all you do is drop the powers down, so it becomes 70, and subtract it by 1. Drop 2.5 down, so 2.5 times 14 gave us 35. Subtract by 1, you get 1.5. Easy step. And now because it's a turning point, you can set this equation to 0. So then you can have 70x equals 35x power 1.5. And then just make x a subject. So divide 35 across, and all of this here becomes 2. Divide x across, so you get x to power 1.5 over x. And remember, this is x power 1. So to do this, when you're dividing terms, you subtract the powers. So all of this becomes x to the power of half, or 0.5. And lastly, to get x, you just square both sides. So then you get x equals 4. Or you could use the cube root button and change the 3 into a half. So it looks something like this. So instead of 3 here, cross out on the calculator and write 0.5. So let me just change that to 0.5 or half. And this again will give you 4. So that's if you're not too sure how to work with these. Okay, so that's the easy bit. So again, we're trying to find the coordinates A. So now we've got the x value. All you want to do is plug the x value back into either the y equation to get the y coordinates or over here. Both is fine. And when you do that, you should get 112. So this means that this coordinate here is 4 and 112. Okay, not bad. Oh yeah, so just be clear, so it has a height of 112, and we can see now, just to expand this one a bit, oh wow, that's terrible. It has a width of 4, so 4 to B. So now we need to know what B is later. So let's have a look. The curve crosses the x-axis at the point B. So like I said, this paper is easy. This question is easy. So if it crosses the x-axis at point B, this means that it has a y value of 0, which is kind of clear because it's on the ground. So now you just plug in y equals 0 to this equation here, and then you solve for x. And when I did that, what did I do? So I wrote that down, so always make your assumption. So 0 equals this, and then you know what, you're right, use the original equation because it's already factorized. So you can say therefore 0 equals 7x squared, or 0 equals 5 minus 2 root x. And solving both, well, that left side is easy. You just divide by 7, square root, you still get 0. But then that's useless because x equals 0 is the point where it crosses over here, and we don't need that. We want B. So likely the solution will come from the second pair. So yeah, so plus 2 root x across, divide by 2, and then square both sides. Your x coordinate should be 25 over 4. And that's it. B is 25 over 4. So yeah, so I mean, I'll be honest, there's not really much hard things here. It's only 2 marks, that's 5 marks. These are easy marks, okay? Now, finally, here comes the big boss. So the finite region R, which is over here, blah, blah, is bounded by the curve, the line through A, parallel to x-axis, and the line through B. You know, let's just go ahead and update this. So we had a B coordinate of 25 over 4. So that's this coordinate here. Now, in other words, it just wants us to find the area of R. So let's look at this one more time. If you got the region R here, you can clearly see that there seems to be like, to get this shape, you can see that there's a rectangle here. Now, the area of this part here is only found by using integration, yeah? Because remember, the integration is used to find the area under a curve, not above it, under it. So if you integrate from, let's say, 4 to 25/4, so this entire width, you're technically integrating the area underneath it, below this curve, up until here, so all this purple region. So you can say, okay, if we do the area of a rectangle, which has a width of whatever the difference between 4 and 25/4 is, and a height of, what is it, 112, and subtract it from the purple region, you got your answer for R. So set up like this. So I wrote it here. So you can say the area, so the entire rectangle is 2 points. So yeah, the difference between 4 and 20/4 is 2.25, times it by 112, and you get 252. So that's the whole area, the whole block, A plus R. And then subtract the area A, which is integration, and you just integrate from the limits 4 to 25/4. So, and that should be like this. And then here's our curve, as we found earlier. And that's it, we're done. Just integrate, plug in the x values, and you solved it. So integrating 35x squared, you just raise the power by 1, so it becomes 3/3. Raise 2.5 by 1, so 3.5/3.5. And then just plug in, firstly, replace all the x values here with 25/4 to get roughly 406.9 ... And then replace every value here with 4 to get about 704/3. Okay, so and then solve this, and then when you solve this, do 252 minus your result, and you should get an area or region of R of about 79.77 units squared. And that's it, all solved. That's literally integration in a nutshell, and all of it done. And just to be clear, they wanted in 2 dp, 2 decimal places. So yeah, if you guys enjoyed this video, and I mean this whole paper as a whole, give me a like, share with your friends, and any positive feedback, comments, and any particular questions, give me a shout. I'm here. I'm gonna be here every single year doing this over and over, and probably until the day I die. Who knows? But yeah, I hope you guys enjoyed it, and have a great day. Ciao.